Now let's do this question. Example number 6.8. I'll tell you, a metal bar 70 centimeters long and 4 kilograms in mass is supported on two knife edges placed 10 centimeters from each end. So we have a metal bar. So draw the figure. Let's draw together. Right. So we have a metal bar like this, which is supported on two knife edges. There are two knife edges. Okay. So you're putting this on two knife edges like this. One right here. All right. One right here at 10 centimeters. And the other one is also at 10 centimeters on the other side. Okay. Look at this. So both the knife edges are at a distance 10 centimeters. A metal bar 70 centimeters long. So it has a length of 70 centimeters only. So 10, 10, 20 should be 50 there. So can be right here, right? So this is 10 centimeters, right? Okay, right here I have another one. This is called a knife edge. And you're placing two knife edges at this distance. Okay, right. So what are the distances? The total length is 70 centimeters. And this distance is given as 10 centimeters. Mark it. Even this distance is 10 centimeters. The extended portions are 10, 10 each. This distance will be 50 centimeters. All right. And the mass is 4 kilograms. 4 kilograms. 4 kilograms. Where is the weight acting through this? Where is the weight of this body acting through? Weight of this body is acting through the center of mass. Where is center of mass? Right in the middle. You can draw the figure. This is the center of mass. The weight of the meter scale is acting through the middle. Weight is equal to mg. Mass is given as 4. So it is 4 times g. Okay. So weight of the meter scale is acting through the middle. It is equal to 4 times g. Mg is equal to 4 times g. Then what? A 6 kilogram load is suspended at 30 centimeters from one end. So you're putting another load at what distance? 30 centimeters from one end. 30 centimeters from one end. So it should be somewhere here, okay? All right, somewhere here. At 30 centimeters, you are keeping a weight suspended. Look at that. A weight is suspended right here. So draw the figure. There is a weight suspended right here. Weight suspended right here. All right. You can put the weight there. All right. So this is the weight you are keeping. All right. So weight of that body acting down is what? Weight of the body acting down. That is also given. That is given as what? Let's put the value. Weight of that body, additional body, is weight is equal to mg again. That is equal to 6 times g. 6 times g. Okay, 6 times g. Find the reactions at the knife edges. Assume the bar to be of uniform cross section and homogeneous. Draw the figure. I'll tell you how to do it. Did you understand the situation context? We have a long metallic rod. The length of the rod is 70 centimeters. Okay. So there are extended portions, 10 centimeters on this side and 10 centimeters on the other side. Okay. These are knife edges. And right in the middle, weight of the scale, weight of the rod is acting through the middle. It is mg, that is equal to 4g, because mass of the rod is given as 4 kilograms. Additionally, you have kept a weight here. At what distance? They say what? It is kept at a distance of 30 centimeters from end. 30 centimeters from end means this distance must be 20 centimeters. Am I correct? Because from one end they say this is 30. So this is not drawn to the scale, okay? All right. This is 30 centimeters. From one end it is 10. This must be 20 then. Then what? I have two more forces here. One force is the normal reaction acting. What is normal reaction? Normal reaction acts through the point of contact. Look at that. For every action, there is equal and opposite reaction. Look at the knife edge. This is where the rod touches the knife edge, right? Right there, there is a normal reaction acting, which I can call R1, and another normal reaction here, which can be called R2. R2 can be called R2. So the normal reactions are acting at R1 and R2. They are acting at the two knife edges. Hope you have a picture of this in mind right now. Okay, I'll illustrate the situation one more time. We have a long metallic rod. The length of the rod is 70 centimeters. Extensions are 10 centimeters on either side. The knife edges. Okay. The weight of the rod is acting through the middle. Weight of the rod is acting through the middle. Okay. It is mg, that is equal to 4 times g. Then the additional weight you have kept here is mg, which is equal to 6g, 6 kilograms. Okay. Then they say this is at 20 centimeters because they say 30 centimeters from one end. If this is 10, that must be 20. All right. And the normal reactions are, normal reaction always acts through the point of contact. Point of contact. The knife edge, that is the point of contact, right? Okay. So normal reaction is acting up. Normal reaction is acting up. Now I'll tell you, the rod stays in equilibrium. Equilibrium means what? There are two types of equilibria. Number one, translational equilibrium. Number two, rotational equilibrium. Translational equilibrium means sigma F is equal to 0. Rotational equilibrium means what? Sigma torque is equal to 0. Okay, I repeat one more time. There are two types of equilibria. One is translational equilibrium. Net force acting on the system is equal to 0. Sum of all forces acting on the system is equal to 0. Got it? And what is rotational equilibrium? Sum of all torques acting on the system is equal to 0. So let me write the forces, okay? What are the forces acting on the system? R1. Look at that, R1. R1. Second force is R2. Correct? R1, R2. Third force is, tell me, 6G. Fourth force is 4G. Am I correct? Look at that. One force is R1, normal reaction. Second force is R2, normal reaction. Then weight is 6G. Weight is 4G. Okay. But remember, I must take them negative. Why negative? Because the upward forces are taken positive. By convention, downward forces are taken negative. Correct? So this normal reaction is upward. This normal reaction is upward. Both are positive. Downward weights are negative. So tell me what you're going to get. R1 plus R2 is equal to. So what I'm getting right now is a relation between R1 and R2. R1 plus R2 is equal to 6G and 4G go to the right side. Oh, this is 0 on the right side. Okay. What is it now? That is equal to 10G, or R1 plus R2 is equal to, if I take G value as 100, if G value as 10, that must be 100. So that is my equation number 1. This is my equation number 1. Look at that. I got equation number 1 now. All of you understood until here? Yeah. Sum of the forces acting should be equal to 0. Net force acting on the system should be equal to 0. Okay. Okay. Right. Write this until here. All of you got it? Now, let us see the second case. We need rotational equilibrium as well, right? What is the condition for rotational equilibrium? I said before that torque should be equal to 0. Sigma torque should be equal to 0. Correct. I'm going to write the torques now. Listen to me, please. I'm going to take the torques about center of mass. Do you remember what I said the other day? Torque is equal to force into perpendicular distance. Torque is equal to force into perpendicular distance. Remember, you're going to calculate the torque about this point, center of mass. Okay. How to take it? Force into perpendicular distance. Force into perpendicular distance, right? Okay. So let us take it. Listen now. Right. Tell me, first force, I'm taking this R1, force R1 into, what is the perpendicular distance? Look at this. First force is R1. The perpendicular distance is this, right? Correct. Look at this. This is the force acting and this is the perpendicular distance, isn't it? How much is the perpendicular distance? This is 20. This is 5. How do I know this is 5? Because The middle point is 35, right? Total length is 70. Total length is 70. Total length is 70. And this distance must be 5 then. Why 5? Because total length is 70. If this is 10, this is 20. 10 plus 20 is 30. That must be 5 then, right? 35 should be there, no? 70's half is 35. Middle point should be 35. Okay. So let us take each torque. I'm taking the torque given by this R1 into this distance is 25. Plus, next one. Tell me, look at this. What is the torque given by this body, this weight? 6G into, this is the weight acting, right? The distance is how much? Look at that. This weight is giving a torque. That distance is 5. Distance is 5. Plus, this weight is not giving a torque. Why? Because it is acting through the center of mass. We are finding torque about the center of mass. So distance from that point will be 0, right? Correct. So then the only thing that is left is R2, right? Tell me, R2 into, what is the distance to this point? Can you tell me this distance to this point? What is this distance? This is 10. This must be 25 then. Am I correct? Why? This is middle point, right? Middle point of the rod is 35 centimeters. If this is 10, that must be 25. Correct. So force into perpendicular distance, R2 into 25. R2 into 25 should be equal to 0. I'll do it one more time. Look at this. This is what it is. Nothing. It's very easy. I'm just equating the torques to be equal to 0. What are the torques? Look at me one time. This force into perpendicular distance. R1 into perpendicular distance is 20 plus 5, 25. R1 into 25. Plus this weight 6G into this distance, that is 5. 6G into 5. Plus R2 into this distance, it is 25. Okay. But you know, I have to give sign convention like before. How to give sign convention? If you remember, anti-clockwise torque is positive, clockwise torque is negative. Anti-clockwise torque is positive, clockwise torque is negative. Listen to this now. Look at this. If I keep it this way, this torque is in which direction? It is trying to push it, right? Pull it up. Am I correct? Am I correct? This force is causing what torque? It's clockwise, right? Correct. Look at that. I'm holding this by this center of mass, and if I pull this by R1, where is it going? It is going in clockwise direction, right? So that torque is in fact a clockwise torque. That torque is in fact a clockwise torque. Am I correct? Clockwise torque should be given negative sign. All right. I'm not done yet. Let us do the second one. How about this one? I'm holding it here, and this one is pulling it down. In which direction? It's going this way. Going this way means anti-clockwise torque, right? This weight is causing which torque? I'm holding it here. This is being pulled down. This anti-clockwise torque, right? Anti-clockwise should be positive. So that torque should be positive. This is creating an anti-clockwise torque. Okay, anti-clockwise torque. Okay, correct. This weight is creating an anti-clockwise torque. It is creating an anti-clockwise torque like this. Anti-clockwise torque. Now the third one, how about that one? Look at this. I'm holding it here and it is pulled up. Look at that. This R2 is pulling it up. It's going in this direction, right? Which direction? No, it's being pulled up in this direction because the center of mass is right here, no? So it's being pulled up in this direction. So it's anti-clockwise torque. So that is also what? That is also anti-clockwise torque. So this is giving an anti-clockwise torque. Anti-clockwise torque like this. All right. Anti-clockwise torque should be given what? Should be given positive sign. And now I'm done. Look at that. I can take this to right hand side. What do I get? R2 into 25 minus R1 into 25 is equal to 6 into 10, 60. G is 10, right? 60 into 5, 300. Oh, then I'll take it the other way. Okay. I take what? I take this to the right hand side. R1 into 25 to the right hand side. R1 into 25. R1 into 25 minus R2 into 25 is equal to 300. Why 300? 6 into G is 10, right? G is 10. 60 into 5 is 300. It's finished. Now let us simplify this. I'm cutting everyone with the 25. 25. 25. It is 12. So what is my new equation? R1 minus R2 should be equal to 12. 12. That's equation number 2. Now you know what to do, right? Cancel by 300 with the 12. Did we make any mistake?
No, sir, it's correct. We're canceling. We're taking common as 5, right?
No, 25. G is 10. 6 into 10 is 60. 60 into 5 is 300. But 300 is there, no? I'm cutting everyone with 25. 25 is cut. 25 is cut. That should be 12. 25 into 12 is 300. But still, that should be 60. Then again, one more cut with 5. Correct. All of you understood until here? Let me finish this off. I'll explain one more time, okay? So now that you got two equations, you can solve them, okay? How to solve them? Just write them side by side. What are we going to get? If you write them side by side, I'm writing it here, R1 plus R2. R1 plus R2 is equal to 100. That is equation number 1. R1 minus R2 is equal to 12. Equation number 2. Solve them, add them. 2R1 is equal to 112. So that will give you R1 as 112 by 2. That is equal to 56 Newton. Final answer is 56 Newton. Okay. Final answer is 56 Newton. You can substitute this. No, check it again. R2 is what? Why R2? R1 plus R2 is 100, no? R1 plus R2. R2 should be 54. Say 44 then.
Yeah. 40.
Then sign convention must have gone wrong. Check it again. I'll do it again. Don't worry. So R1 minus R2 is equal to 12. I can find R2 from this. R2 is equal to R1 minus 12. 56 minus 12. That is equal to 44 Newton. Okay. In textbook, the answers are slightly different because they have taken exactly 9.84 G. All right. Answers will be slightly different then. All of you understood this?